Before we start, we want to give a plug to our Resilient Together partner, Still Serving Veterans. They're a nonprofit that helps veterans with no-cost services that help position them in quality, meaningful civilian careers, navigate and access their VA benefits, and make the best of their time after service. We'll include a link to their website if you'd like to learn more, as well as a donation link if you'd like to help support their work. At Orolia, we're donating $10 per registrant from this Defense Days webinar series to this cause. But beyond donations, they're mostly grant-funded, so they always need more veterans using their services. So if you are or know of a U.S. military veteran who could use any of the services you see here, I've included the contact info of their Chief Programs Officer, Jim King, in the post-show email, and you can reach out to him directly to learn more, or if you'd like to refer a friend. Thank you, Still Serving Veterans, for the service you do, and thank you all for joining us today. Enjoy the webinar.
Let's go ahead. Hi, my name is Alex Payne, and I'm an applications engineer at Orolia Defense and Security. Today, I'm going to give a brief introduction to open systems and benefits afforded by this architecture. Next, I will provide an overview of the CMOSS suite of standards and how Orolia is pursuing this open standard. I will then go into the assured PNT technology that Orolia offers and benefits of this capability in an open systems architecture. What is SOSA? Sensor Open Systems Architecture enables government and industry to collaboratively develop open standards and best practices to enable, enhance, and accelerate the deployment of affordable, capable, interoperable sensor systems. SOSA creates open system reference architectures applicable to military and sensor systems in a business model that balances stakeholder interests. The architecture employs modular design and use widely supported consensus-based non-proprietary standards for key interfaces. Some advantages of an open systems architecture. As technology required by tomorrow's warfighter evolves, open standards adapt to future needs quickly. An open system approach translates to a reduction in costs for integration, maintenance, and future enhancements. As the needs of an in-service platform grow, the capabilities too must grow. Open standards enables that scalability without being locked into a single model. Open systems allows for sensor assets to be used across platforms easily. As the pace of technology advancements continue to grow, the ability to support that capability evolution with minimal service interruption is critical. And with an open systems approach, capabilities are not restricted to a single vendor. Now we'll talk about CMOSS. What is CMOSS? CMOSS is a suite of standards that support the reduction of the size, weight, and power of C5ISR in electronic warfare systems while increasing their flexibility and adaptability by enabling the sharing of hardware and software components. These standards have been defined to help integrators move the implementation of C5ISR capabilities away from the use of costly and complex separate boxes on individual platforms. Why CMOSS? At the core, C5ISR EW systems use many of the same technologies, but they are not always compatible between systems. CMOSS seeks to create a common architecture that these technologies can integrate into and providing benefits beyond current capabilities. Using a single common box across platforms for all of the sensors required, regardless of vendor, is the innovation that can facilitate success for the warfighter. CMOSS architecture. CMOSS is composed of 4 main layers interoperating together between vendors. The software layer is open to allow for portability across platforms. Functional decomposition pools, radio resources like antennas and amplifiers for communications, electronic warfare, and signals intelligence. The hardware layer supports sharing of data services such as position, navigation, and time. Network layer permits legacy systems to integrate with modernized sensors. Sole-sourced assets become a replaceable card or software or interface, regardless of the vendor or source. Assured position, navigation, and timing is one area Orolia is pursuing a CMOSS and SOSA compliant solution. Our Versa platform provides position, navigation, and timing assurance in a flexible, configurable device that allows your PNT reliant system to function in disrupted GNSS environments. The Flex Fusion sensor fusion engine combines GNSS, inertial measurement, other signals of opportunity, and high-performance timing oscillators with GNSS interference detection and mitigation. VersaPNT minimizes size, weight, and power and cost by combining PNT functions normally achieved through multiple independent subsystems, and it is ready for integration into ground, air, and maritime platforms. The Orolia VPX time processor is a complete synchronization system in a VPX form factor. Combining the VPX form factor and VersaPNT sensor fusion, we can achieve a CMOSS compliant assured PNT solution on a card. Here we have the CMOSS PNT card, or CPNT. This CPNT can offer M-code, GPS, and multi-constellation GNSS capability, a high-performance internal time base, an inertial sensor to manage potential loss of GNSS. It serves as a GNSS time and frequency source with NTP and PTP time server, and it allows the integration of future PNT signal sources and incorporates protection using threat detection with Broad Shield. Assured PNT by layer includes the protection for the CMOSS PNT card and translates into victory compliance, high precision clock oscillator, interference detection, other signals of opportunity, integrated IMU, M-code GPS, and the Flex Fusion engine to provide an assured PNT solution. Capabilities expanded through layers of an open systems architecture provides the environment necessary to scale up. Full stack performance in open system. By integrating an assured PNT solution with other capability sets within the open system architecture, we enable success for the warfighter. An open standard approach can increase resiliency to interference by fusing the capabilities of multiple sensors of multiple systems and provide the best possible result for the mission. The performance potential in GPS degraded and denied environments relies on a single sensor instead of a full stack and increases vulnerability in a contested environment. By using a layered, collaborative, open system architecture, assured PNT as a layer of protection. In the red, here we can see the receiver without PNT assurance, and we can see the trajectory in a contested environment. In green below, an assured PNT trajectory reflects the improvement to the navigation in the overall system performance in the same contested environment. Relying on all available sensors within the modular system ensures resiliency and success of the mission. Monitoring capabilities include real-time readouts readily available in machine and human readable format for quick diagnosis in response to changes within the environment. The sensors within the open system provide independent diagnosis, and allow a card to be swapped out with a spare card in moments instead of reinstalling a new box. If a sensor fails, the open system reports, diagnoses, and could adjust accordingly with other capabilities within the platform. Broad Shield on CPNT includes threat detection in a contested environment to ensure all sensors react accordingly and adjust capabilities in response to the threat. Broad Shield is a software library consisting of many patented algorithms designed to detect interference, then immediately report the disruption to the PNT system. Once interference has been detected, the system adjusts and implements the appropriate countermeasures to ensure mission success. The web user interface for the CMOSS position, navigation, and timing card, an open standard architecture provides capabilities as cards and shared processing resources. Monitoring and responding to changes in the environment is built in and autonomous, enabled by the interoperability between C5 ISR systems and platforms. Configuration of sensors in an open system may occur on their own once installed in the CMOSS chassis. Instead of individual configuration for each unique vendor system, an open system approach would allow a common architecture to allow enumeration of each sensor on a given platform. Here we can see the user interface that the soldier can respond to. Here we can configure all the devices. In an open systems architecture, these functions would be handled by the system. Here we can go and look at Broad Shield. And show our current threat environment status. This gives real-time readouts, carry to noise ratio, number of SVs used, and the threat detection. We can also locate and see the SVs in view and the relative power ratio. We can pull up a map. Other abilities through the web user interface include monitoring your GNSS signals, management, to configure your INS settings, all functions within the web user interface in an open systems architecture would be handled at the front end. One interface for all sensors. Here we're seeing the VersaPNT. Flashing light on the side indicates our navigation status. And we have our timing status and our reference status for satellite vehicles used. In conclusion, SOSA is a tremendous opportunity for government and industry stakeholders to work together and facilitate the best possible solution for any mission. CMOSS is an open system architecture which affords a common integration point for sensor capabilities across all platforms. It ensures interoperability among vendors and can eliminate sole sourcing restrictions commonly faced today. The CMOSS PNT card is one sensor in the open system that adds layers of protection to mitigate the effects from threats and maintain assured position, navigation, and time. Thank you all for your time today.
All right, thank you, Alex. We had one question come in already, and for everybody else on the call, if you have questions for Alex, there's a tab on the right-hand side that says questions. You can click on that and add your questions there, and we'll answer them now. The first question is, which M-code common GPS module does Orolia's CMOSS product work with? L3, BAE, and/or RTX?
Yeah, so we're integrating with several receivers. Currently, we have integrated the BAE receiver into the VersaPNT.
All right.
Good question. Thank you.
Someone else asked, it'd be nice to have a contact person for all 3 days and get the slides for all 3 days. I think we might have had an issue with the first email the first day. We're going to resend those and we'll make them available on the event pages on Orolia.com. So we will make sure to get you these slides and the contact people to follow up. I did publish a poll in the polls tab that asks if you would like to follow up with our applications teams. You can just click yes to that. We know who you are, and we will find you. We have another question came in. How many coax inputs and/or outputs are required on the VPX backplane connection?
How many coax connections?
Yeah.
I believe it's 4, but I may be mistaken. I can come back.
Okay, I think it's 4. All right, let's see. Any other? All right, if there are no other questions, we'll wrap it up there and give you all some time back. We had one come in? Department of Defense PNT policy is to prioritize M-code over other sources and DoD receivers. How does Orolia do that?
That's a good question. Orolia uses the M-code receiver as the primary reference. And if we go back to the user interface, you can set your priority. So the priority is manually set, and it would select the M-code receiver as primary reference.
Oh, that's cool. What are some of the other options in there?
Sure. So you can use the local system refers to the internal oscillator. You can feed in an ASCII input. You can ingest NTP protocol and PPS and other signals of opportunity and the have quick input.
All right. Are there any other questions from the audience today? Okay. Well, with that, we'll close it. Thank you very much for your time, Alex. And everyone will follow up with an email with these slides and a link to the replay if you want to watch it again or if you missed anything. Thank you all for your time.
Thank you.